Okay, so I'm live, and so let's start off from where we left in my last stream. And to recap what I streamed previously, I discussed the bare minimum, the system design of YouTube, a very popular video platform. I think video sharing, watching videos. So YouTube deals with three problems, that is how to handle a lot of videos, and the second is low latency, because even though if you're successfully able to handle 4K footage and millions of video, if the end user is finding it difficult to view, retrieve, then it defeats the purpose. And the third is, for every video there is a lot of write heavy metadata, which is view count, subscriber count, share count, things like that. So today, I'll be diving deep into the massive video storage, how YouTube efficiently handle this. So to begin with, even I'm not so thorough with YouTube system design, but with the help of Claude Code, I'll figure things out on the way. And this is actually how you can improve yourself as a programmer. You don't need to know everything, but the only prerequisites are that you should be extremely curious and willing to spend time learning new things. So I'll say in youtube.md file, it mentions massive video storage. So explain how YouTube handles a lot of videos and storage efficiently. So I haven't given too much context in my prompt, because I want to see what it generates, and then based on that I will ask more follow-up questions. But let's see. Even I don't know how YouTube does that. So okay, this is system design study doc. Okay, so raw upload, object storage, not a database. Fan out, fan in, immutability, statement storage enables net effect. Okay, this is a system design study doc. Okay, blah blah blah. So the first point is raw upload, object storage, and not a database. Videos never touch a relational database as blobs. The upload path writes the file straight into a blob internally. Colossus at Google. Okay, so I think this is what they're using at YouTube. The DB only stores a pointer or metadata, video ID, storage path, owner status. Okay, and blob stores are purpose built for huge, immutable, rarely modified objects. Cheaper GB, horizontally scalable, and they don't choke on large binary writes the way a relational DB. Okay, then the second point is transcoding storage equal to multiplication, done async. One upload becomes dozen of stored file, multiple resolutions times multiple of codecs times multiple container segment format for streaming. So I don't know what exactly this means. Uh, in particular, multiple container segment formats for streaming. That's why transcoding is decoupled via message queue. While workers pull jobs off the queue at their own pace, the queue also enables fan out. One upload event can trigger transcoding, thumbnail generation, content ID and copyright scanning, moderation checks in parallel, all independently retrievable if a worker crashes. Different codecs exist purely for storage bandwidth trade-off. AV1 compressor is 30% better than but costs more CPU to encode. Okay, so YouTube encodes AV1 mainly for popular videos where the bandwidth saving at scale justify the extra compute. So my next question is, how does YouTube decide which video is popular? I assume based on views, likes, shares, and engagement. But if a video is uploaded, then how do you decide it's going to be popular or not? Based on the previous trend of the YouTube channel that is already uploading. Now we have deduplication and compression and scale. Okay, so let me just write down um, what I just did. So a short and brief summary. So we have the YouTube handles massive nodes. Okay, so first one is I'll add this date 17th July 2026, and I'll say the first one is raw uploads. So what happens? mm, Yeah, we have the raw video, and then it goes to a blob, something like S3, um, internally coalesces at Google. Maybe I can add a side note what is colossus, something like that. Um, and then a pointer, the DB only stores the pointer. The database stores the pointer to the blob. Okay, probably along with video ID, storage path, owner and status. Fine, and then that's it. Okay, now then we have the transcoding process. Second is transcoding, which is storage multiplication done asynchronously. Storage multiplication done asynchronously. Now one upload becomes dozen of stored file, multiple resolution, multiple codecs, and multiple container segment. Okay, so one upload is converted into different multiple resolutions, 144p ranging up to 4K, then multiple codecs. Uh, Let me copy these values. Um, and then we have multiple container slash segments. So I have a bunch of questions which I want to clarify. I'll note them down at the top of my readme.md5. What do you mean? What is multiple container segment formats for streaming means? That's why transcoding is decoupled via message queue. So this is done in the background since encoding is CPU heavy and slow. CPU. I can also say that encoding is CPU heavy and slow. The queue also enables fan out. One upload event can trigger thumbnail. Okay, so we have fan out, which means uh, a upload function will trigger thumbnail generation, content ID or copyright scanning, and then we have the moderation checks. So different codecs exist purely for storage and bandwidth trade-off. So what are codecs? I assume they are called video format, but still I want to know more about them. Um, Especially this is these concepts can also be applied to Netflix, Amazon Prime, or any other streaming platform. So it's not just limited to YouTube, but almost every platform which is heavily focused on videos, you can use these same system design concepts over there as well. Um, so AVN compresses 30% better than VP9 H.26 but costs more CPU to encode. So YouTube encodes it mainly for popular. So I can just say codecs. I'll add this point over here and then I'll expand on it once I'm done with this prompt. So AV1 compresses 30 approximately 30% better than VP9 or H.264 but costs more CPU to encode, and also AV1 is used for popular video. I think NKBHD, a very popular tech YouTuber, did one experiment where he uploaded a video, downloaded it from YouTube, again uploaded it, and again downloaded it, and he did it more than like 1000 times, and then you can clearly see um, the difference between the raw footage and what YouTube does behind the scene. So I highly recommend that you can go and check that video out. Then it performs moderation checks and deduplication and compression at scale. Content-based storage. Now, what does this mean? Identical or nearly identical uploads, re-uploads, pirated key encodes can be detected via hashing or fingerprinting and reference existing transcodes instead of storing duplicates. Okay, content-based storage. So, tired storing for recently uploaded trending content sits on faster storage tier. Cold, fairly watched long tail videos migrate to cheaper, denser storage. Same pattern as any large-scale blob system. Ensures coding, not full replication. Instead of keeping S3 full copies of large-scale blob stores, use erasers encoding, split data into fragment, plus parity, reconstruct from a subset, get similar durability. And so yeah, this is not just that videos that aren't watched so often are moved to a cheaper, denser storage, but also I heard recently that Meta decided to degrade, uh, I shouldn't say degrade, but only keep the copy of that video with the lowest resolution, not the highest, because it's not being used and it's unnecessarily taking up too much space. And that decision caused a lot of backlash among other people because I don't know if they implemented it or not. I'm not sure about it, but this actually happens behind the scene. So one thing that I can do is, instead of writing everything down, I can say draw IO, start diagramming. So this is from my previous video. You can see the user uploads a video, then we have this three, not exactly S3, probably colossal, and then in the background some transcoding pipeline happened, and then there's a CDL Google has its own special network of content delivery network, so that the video which is being requested is physically closer to the end user, therefore offering low latency and much better streaming. Then we have client playback and user watches the video. So I think, and then we have other features such as searching, recommendation. Then you have the YouTube Studio, especially for uh, video maker. So let me expand on this one. I will say YouTube system design, something like this. Rename and so in the transcoding process, probably I'll add 3 circles. So we have multiple resolutions, multiple codecs, multiple codecs, and then multiple container slash segment, multiple container, or you can call them segments. And these all take place during the transcoding process. So I can say when we are transcoding, mm, now I'm thinking about where should I put copyright checks or content ID generation, um, which are all these 3 things. So content based storage. Okay, let's go through this entire prompt first, and then based on my understanding, build a system design, and from there I'll ask Claude, is there something that I miss? Fine, deduplication and compression at scale. So third is deduplication and compression at scale. So I have content based storage, identical or near identical uploads, pirated read encodes can be detected via hashing and fingerprinting, and reference existing transcodes instead of storing duplicates. No clue what this means. So I'll just copy this entire text since I don't know how to summarize these points because I don't know what this means. But I know what is tied storage is. I'll say this is point A, then followed by point B, tired storage. So the hot popular videos uh, sits in faster storage, and old slash here old doesn't mean that it's not popular. I would say those videos which attract less views, because old video can also be popular. For example, music, uh, low watched or less frequently watched videos are stored in cheaper and slower storage. So this is just a follow-up question which I want to clarify. Does YouTube uh, only keep the lower resolution footage for videos that are hardly watched? And then erasure encoding, not full replication. Instead of keeping 3 full copies of every video, large-scale blob stores use erasure coding. Split data. Okay, what is erasure coding? And the third point is erasure coding, not full replication. Okay, understood. Instead of keeping 3 copies of every video. Okay. Yeah, I can also ask how many copies of the same video. How many copies of the same video does YouTube create as backup? So this is what erasure coding is. Split data into fragment plus parity, reconstruct from a subset. No clue what this means. So let me just blindly copy this entire text over here. Now immutability with an editor. Your question on line. Okay, so it did pick my previous question which I have not answered. Videos are immutable once transported. That doesn't mutate, store, block it either. Re-triggers the upload transport pipeline on the edited frames. Stores edit metadata that applies at serve time via the manifest without re-encoding. Oh, okay. So I think probably it keeps the timestamp or something like that where you have edited or made any changes to the video, then those changes are served from the original and then those changes are applied to the original raw video which was uploaded. So in the sense, whatever is uploaded is there forever. It's just a mask that you put on your videos to show to the rest of the world. Segment storage enables efficient partial delivery because delivery uses adaptive bitrate. Streaming videos aren't stored as one giant file per resolution. They are chunked into smaller segments, a few seconds each. This matters for storage too. Segments can be independently cached, independently regenerated if one encode job fails. And net effect storage efficiency comes from 3 separable decision blocks stored instead of db for bytes. Okay, async multiplication into many derivative instead of serving one master file live. Okay, this is the transcoding process. Duplicate tiering to avoid paying full replication cost per copy. This ties into 3-layer question. CDN caching is really a fourth tier on top of the hot segment pushed into edge origin. Want me to go through a message queue functionality question like SQL versus split next? Um, okay, so these are the main 3 points how YouTube uh, mostly handles videos. And I had a couple of questions from my previous live stream. Does the message queue offer any other functionality other than transcoding? What different format? Why? Okay, let's find out the answer for this question. Obviously, why transcoding is decoupled from upload request, because then it's going to make the upload request a lot slower, and also if transcoding fails then upload request will also fail. Then um, so yeah, I think I still know the answer to this question, but I'll ask Claude if my understanding is correct. Let's ask this question: why different formats like AV1, V9, multiple codecs for the same video? It's a device compatibility versus compression efficiency trade-off. No single codec is both universally supported and maximally efficient. So YouTube stores several AVAC, AVC. Nearly every device ever made, old phones, smart TVs, browser, game, console, can decode in a hardware. Worst compression of the three biggest file size for a given PPS. Google's own codec, mid-tier. Newest, most efficient, most expensive to encode. Why not just pick one? At YouTube scale, a 30 to 50% bitrate reduction from AV1 to is enormous to aggregate egress cost, but only worth the encoding CPU cost for videos that will be watched a lot. This is why AV1 encoding is generally prioritized for popular trending video, not applied uniformly to every upload. Has to be amortized over enough views. Client negotiates at playback time. The player reports which codecs resolution it supports. Decode cost matters too. Even if a device can software decode AV1, it may drain battery faster than hardware decoding. So codec choice isn't just about files, it's about client side trade-off too. So okay. So H.264 is universal in the sense almost every device can decode this in hardware. So we have the H.264. So this is the baseline. So nearly every device can decode H.264 and worst compression of the three biggest file size for a given as the biggest file size, uh, the worst compression takes high compression time. Okay, and YouTube has to serve something to devices that don't understand anything new. This is fallback tier, and this is the fallback tier for devices which do not understand modern encoding. So once I was giving an interview, the interviewer asked me what is the difference between encryption and encoding. What is the difference between encryption and encoding? So UTF-8, UTF-16, those are encoding. That is what I think the character sets that are permissible, something like that. And encryption is related to cybersecurity, that is convert the data into some gibberish over the network or anywhere where you want to securely store the data. Uh, for example, JavaScript, decrypt or hashing the password is an example of encryption. Now we have the VP9. This is VP9, Google's own codec. Google's own codec. This is mid tier. royalty free. Google owns it, unlike which has patent licensing cost at scale. Okay, Google's own it, therefore no patent licensing costs at scale. Supports supported by most modern browsers, but not older hardware. Google Balance are widely supported enough, meaningfully smaller than. And then we have the AV1, newest, most efficient, and most expensive tool. Newest, most efficient, and the most expensive to encode. So, first of all, with this question in mind, why do we need to encode a video which is uploaded to YouTube? I think, write this question down. Why encode a YouTube video? Does encoding means compressing? I don't know. Let's find out. Encoding, oh, okay, here means compression, converting raw, uncompressed video data into much smaller file. The core reason raw video is unusually new. So what is UTF-8 encoding? UTF is a turning text character into bytes for storage or transmission. The problem it solves, computer only store numbers. To store the letter A, you need an agreed upon mapping from a some number. Old system ASCII character, enough for but nothing else. Different region invented their own incompatible mapping for the language. How UTF-8 fixes this? Unicode assigns every character in every language. UTF-8 variable in 1 to 4 bytes per character. Why this design specifically? Backward compatibility with ASCII. Oh, I think ASCII is not UTF-8. Any old ASCII text file is already valid. UTF-8 byte for byte. Huge reason it won over other Unicode encoding like UTF-16 for the web. Since most source code HTML tags and English text is ASCII, UTF-8 doesn't waste byte padding those characters, which are fixed to 2 or 4 bytes per character regardless. So I think 8 or 16 or 32 refers to the number of bytes each character will be using, and self-synchronizing. You can tell from a single byte whether it's the start of a character or a continuous byte. So a program can jump into the middle of a byte stream and still figure out character boundaries without decoding from the very start. Where you'll actually hit this. If you ever see show up instead of Mojic break, that's a UTF-8 encoding mismatch. A file was encoded in one schema, Latin 1, but decoded assuming UTF-8 or vice versa. Separates from the video byte. Not directly related to YouTube storage, but if you want, I can tie it back. That is, video metadata stored in the DB is UTF-8 encoded text separated from the video byte themselves, which use codecs. Oh, okay. So encoding just means compressing a YouTube video. Compressing a YouTube video. Here means compressing a YouTube. A single minute of raw uncompressed 11080p, no compression at all, can run into several GB at YouTube scale. Storing and transmitting raw footage would be financially and physically impossible. Storage costs would like storage. A codec throws away redundant, imperceptible. Streaming and bandwidth. A compressed file can actually be sent over a network in real time. So encoding solves two problems. Encoding solves two problems. The first one is storage. A codec throws away redundant and imperceptible. A codec throws away redundant or information. But now I have a follow-up question. How does a codec identify which is redundant information? Is because even a picture in pixel is bunch of code, so it probably sees, okay, this frame and the next frame has the same value, it's not changing, so no need to keep this, something like that. Better codex squeezes out more redundancy for the same visual result. Okay. A mostly static background which barely changes frame, so encoders only store the difference. Not full frame and compress what's left. And the second is streaming or bandwidth. A compressed file can be sent over the network. Yeah, a compressed file can be sent over the network. And also is the cost um, aspect to encoding, because storing large file would need more memory, obviously. uh, then you also need to maintain them, more wires, more people. So okay, so why encode really has two layers? Compress encodes into multiple codecs resolution, different goals entirely, transforming data for size or compatibility. Anyone with the right decoder can reverse it. It's not about secrecy. Okay, and transform. Anyone can decode it. So a follow-up question: how is UTF-8 decoded then? Are there also decoders, or is it standardized? Yes, 8 decoding is fully standardized and every language platform ships a decoder for it. Unlike you, it's royalty free but still complex hardware. Code RFC 3629 specs. The decoder isn't a competitive or proprietary thing, like it's just a small universal function. Every runtime implements Python, JS engine, OS level text. How decoding actually works. Each byte leading bit tells the decoder how many bytes make up the current character. Zero first byte pattern. Um, so this is one problem with learning with AI software, because they keep giving you more and more information and then you go into something completely unrelated to what you initially started with, which is I was currently reading about YouTube system design. It's good to know. I'm not saying that okay it's completely useless, but if let's say I'm preparing for an interview, I want to spend as much time as I can learning about system design for YouTube. Okay, so for the time being, what I'll do, um, what should I do? Okay, I can later come to this. Transforming data for DRM or on paid key to reverse. The goal is to unauthorized part. Video can be both encoded, then encrypted. Only authorized player with the license key can decrypt. Mm, 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 mm. So, what is UTF-8 encoding? Is a way of turning text characters into byte for storage. Computers only stores. Okay, so is a way of turning text character into byte. So UTF-8 turning text character into byte, and then the problem it solves. Computers only store numbers, bytes to store the letter A. You need an agreed upon mapping. I think the ASCII code for capital A is 68, I think 68, 69. Um, and for smaller A is 97. Let me confirm this. What is the ASCII code of capital A and small a? Okay, capital A is 65 and small a is 97. Okay, this is correct. Computer only store numbers. The To store the letter A, you need an agreed upon mapping from a some number. Only map 120 enough for English letter. Different region. How UTF did. Unicode assigns every character in every language plus symbol emoji a unique number called code point. Okay, Unicode assign every character in every language, symbols, emojis, a unique number called code point. Okay, is one specific way to encode those code points into byte. Variable length. Why this design specifically? Backward compatibility. Probably I can also note down what is the difference between UTF-8, UTF-16 and UTF-32. Obviously it's the number of bytes, but there might be some more difference. All code point. I don't want to jump too much into this. Probably some other day I'll go through it. The next point which I wanted to clarify are what are codecs, which is important. What are codecs? Coder, encoder. Okay. Codec, a program or a hardware component that compresses raw video or data into smaller format. Encoding a device that processes to make it playable again. What it actually does. Think what are codecs? Codec stands for coder, decoder, and the raw video is just a sequence of full resolution frame, essentially uncompressed. A codec is a specific algorithm that decides how to throw away redundant or okay. A codec decides how to throw away or shrink the information down, and how to reconstruct something close to the original from the and how to reconstruct something close to the original from the shrunk version. Spatial compression and temporal compression. So I think there are two main components to it. Um, Spatial compression and temporal compression. So based on my current system design, um, what I can do, I can create here a rectangle. So this is just my understanding, it might not be correct. With instead of selecting, I'll just select a shape. Okay, okay. So I'll call this codec. Um, where do you select a text box? I'm not used to this draw.io, and matter of fact, I've never used it in my professional career to explain anything to anyone, because I was not part of designing the system, but I have seen others using it to explain the requirement or the code base. Drag element, scratch pad. Okay, so this is the codec. I think probably this would be the encoding part. The decoding probably happens at the client. Within a single frame, similar to how JPEG compresses photos, smooth areas of frame like a blue sky don't need every pixel stored individually. Okay, within a single frame. Okay, I'll just keep note down the name of these concepts. And then we have temporal. Across frame, most consecutive video frames are nearly identical. A talking head video barely changes frame to frame. Instead of storing every frame in full, the codec stores only full frame occasionally. Only the difference. A container slash the file wrap that holds the encoded video metadata together MP4 used in dash file is an MP4 container versus AV1 in a WebM container output combination. Oh, so here in one of my points today, yeah, this one, you have the codec, and then within that you probably have a video, the file wrapper that holds encoded video, the file wrapper that holds the encoded video plus audio plus subtitles and other metadata. Some popular combination are MP4 WebM, MP4 WebM used in dash. So H.264 in an MP4 container versus AV1 in are both meaningful. The codec determines how the bits are compressed. The container determines how those compressed things are packaged and organized on the disk or wire. Oh, so I think this is a very important point. So the codec determines how to compress the video, and then the container determines how to store the compressed frame into a package. So the codec determines how the bits are compressed, and the container determines how those compressed streams are packaged and organized on disk or over the wire. Over the wire means how do you send them on a network over the wire. Tying back to your notes, this is the same concept from earlier, though those are three. So where does decoding happens in YouTube? Where decoding happens entirely offline, never on the server side. YouTube transcode pipeline encodes the video. Okay, so I was correct. Decoding takes place on the client end. So are there different decoding algorithm also? Decoding. So maybe I'll add a arrow over here. Yo yo yo. While it's being played, CDN. Okay, let me check. Delivery. The CDN just ships the already compressed byte. The okay, it's happened on the browser. When you hit play, the video player pulls the compressed streams and decodes them locally but renders pixel on your screen. Why decoding must happen, not the server. And if YouTube decoded videos and send you the raw, you'll get back to the several GB per minute problem from the earlier. Hardware decode preferred modern phone TV have a dedicated chip block for decoding fast power efficient. This is why devices support for a codec matters to so much. If the hardware decoder doesn't support the device either can't play it or has to fall back to slow battery saving is exactly why YouTube keeps multiple one event server side decoding does happen but only during transcoding not playback. Oh okay, so let me delete all this. I don't need it. And I will say a container paste here. Okay, nothing is selected. Basic UML. Okay, I'll figure out how to add the text over here later. I don't want to waste too much time. So this is the encoding part. This is where the decoding happens. So again, CDN sends the encoded video to the client and then it decodes. मैं चलो ये भी बाद में देखूंगा. ठीक है, so I think I made really good progress on this. Again, just to recap, I'll do this through this diagram. So what happens in YouTube, you upload the video, it goes into a blob, and then in the background we have the transcoding pipeline which create multiple resolutions, codec, and multiple containers or segment. So this is what encoding is. And then they have a dedicated CDN server which fetches the encoded files and then are sent to the client's browser where decoding takes place. So H2.9, VP9, AV1, they all have a standardized decoder. You don't need anything special, and I think this is supported by the hardware on your devices. Maybe maybe there is some software to it. Again, which I cannot confirm. So in the next video, I want to find out when you're uploading a YouTube video to YouTube, the YouTube checks if there's any copyright material, how it handles duplicate videos, and third, I want to dive deep into the metadata of each video, how YouTube stores it, and so anyway, thank you guys so much for watching. I'll see you guys in my next video. GGWP.